Hi there, everyone. My name's John McGrath with ACEDES, and we're based in North America in Houston, and we're going to be giving you a presentation today on our coupled fire protection system, which is certainly gaining interest in the North American market for waste recycling, and hopefully it's of interest to everyone. So who are ACEDES? I imagine that's one of the questions you're asking. So we're a combination of two companies, Orgelmeister in Germany, who are the market leaders in the intelligent infrared detection systems that will spot heat sources long before they become a flame, and FireDOS, another German company who make foam proportioners and monitors. They've been working together closely for a number of years, and as the market has grown in North America, they both decided to create a company called ACEDES, and that's the company that I'm with, and we represent Orgelmeister and FireDOS for the coupled fire protection systems. So what does ACEDES mean? It stands for Autonomous Coupled Early Detection and Extinguishing Systems. So fortunately, there's no questions at the end. There's no exams at the end of this, so you don't have to remember that, but that's what the background to it all is. So why are we needed? There's a definite market requirement for coupled systems, and it's based on the growing number of industry fires that we're seeing in waste management facilities. It's growing every year. We've got some figures that we got from waste360.com that show since 2018 there's been a continual growth, and it's growing at the rate of about 12 fires per year, or it has been. That rate does seem to be accelerating. It's predominantly driven by the growing number of lithium-ion batteries that are disposed of in everyday trash from single-use vapes and various other sources. And the issue is that as loaders are moving the recycling material around, it's very easy to puncture these and they can instantly flare up, or if they can sit at the bottom of a trash pile and very slowly start to heat up and create a hotspot, which eventually will become a flame. And there's huge consequences, as I'm sure everyone is aware, to fires in waste recycling centres that can cause millions of dollars worth of damage, and also a loss of production capacity while the facility is repaired. So our objective is to stop those fires before they even become fires. So I've got here the standard fire sort of propagation table that I'm sure everyone's familiar with. It starts off with a heat source, you get some smoke, and then you get the flames. So with an infrared system, the advantage is we start right here at the very beginning of this cycle. So it also keeps on detecting all the way through. So if you were using a flame detector, you wouldn't start to see any indication from it till here. Now, we're going to see it with our infrared detection much sooner, and we'll continue to see it all the way up till it becomes flame, so you don't lose the infrared advantage as you progress through this fire propagation cycle. And you can, the time frame can vary. If you puncture a lithium-ion cell, it might flare up immediately, but generally, if it's at the bottom of a pile of recycling material and it's just heating up, you can be tens of minutes easily before it eventually develops into a flame that you would be able to visually see, or a flame detector could spot. So the fact that we can detect much earlier on in the cycle means that we save a whole lot of time and a whole lot of damage in the process. So how does the system work? it's far easier to show you that in a video. So I'll play a video just now. So as you saw, we've got the PyroSmart Pro camera here. It has an infrared video camera in it, as well as a visual range camera in it, and that allows us to build up a 3D map of the area that's been surveyed, and we build a thermal display of that, and then we can overlay the video as part of that. The thermal display can sometimes be a bit confusing and unintuitive to read, but when you overlay it with a video, it makes perfect sense. We then use that data to trigger any alarms, including pre-alarms, to give you a warning that something is about to happen, just in case there's some action you can take. We monitor everything online. Now, it's not a system that requires an external connection. All of this is housed within your facility. There's no third-party interaction required at all. So once we've detected and determined that it's past thresholds that we need to act, we then control our fire monitors and we aim them in a 3D space. So we actually get the X, Y, and Z coordinates of where the hotspot is, and we aim the monitor accordingly. And then we also can hook up to your fire alarm control panel and send out appropriate warnings or alarms via that as well as sending out messages, alerts to anyone within your organization so that they're aware of what's happening as well. So that's the overview of the system and the sort of stages that it would run through in a typical detection. So the advantage that this system gives, because it's pan and tilt and the camera moves backwards and forwards and then tilts and covers the whole area, we get a lot more resolution as opposed to having one or two or maybe even four fixed cameras with wide-angled lenses, which give a lot less resolution. With this system, in this hall here, we would have the equivalent of, you would need 32 fixed cameras to give you the same resolution as we have with this one. And you can see here. One interesting thing to point out is you can see the green outline. So we map out the areas where we will detect alarms. This is the bay door. If we see a hot thing pass in front of this, such as a loader or a vehicle with a hot exhaust, that's not going to trigger an alarm. And also this area in here is machinery that can get hot. That also isn't going to trigger an alarm. So that's how we set the system up. To give you a more detailed example of it, we've got a facility here that is 180 feet by 100 feet. That's equivalent of 28 fixed cameras to give you the same resolution. And the resolution we are seeing, each pixel on our camera is equivalent of 1.4 square inches. So it's a very, very small area that we're resolving. We can take action on just a single pixel. So that's the type of resolution we're getting. If you took the same facility and used 4 standard flame detector cameras or smoke detectors, they would best case give you a resolution of about 140 square inches. So we've got a 100 times greater resolution because we're using pan and tilt and building up the display of the facility. It normally takes us about 1 minute, maybe 1.5 minutes to scan a full room. We just do that continuously. So we're constantly updating the image. So one of the main reasons we also include a video camera with our higher level of equipment is that there are various things that can look like hot temperatures to an infrared camera, and by using a video camera in conjunction with it, then we manage to eliminate them as false alarms. And here's some examples of it. Obviously, if you've got the hot exhaust of a loader, then that will definitely will be a hotspot. But with the video, we calibrate the system to the vehicles that are using the facility, so we can instantly identify that heat source and that shape is a piece of equipment and not a hot spot in a recycling pile that needs some action. Other things, reflections from sunlight will show up as hotspots. With a video camera, we can eliminate those. So there's a whole bunch of different things we use the video camera of the system for to augment and enhance the infrared part of it. And that's definitely one of the advantages of the system. Then it's not just the fact that we're supplying 2 different cameras, it's the software and AI intelligence behind that runs through all the algorithms to make sure that when we activate, we're activating for a proper situation and not just a false alarm. False alarms take up time, they disrupt your operations, and we want to minimize those as much as possible. So how reliable? Well, compared to a system of 3 or 4 fixed cameras, obviously with our system moving, that has to be a concern. What we have is we run a compressed air line to the system, so we're constantly blowing positive pressure air through the lenses to keep those clear, so we can work in dark and dusty environments. We manufacture our own gearboxes and motors for the system, so we can get a design life of 10 years out of them. So the system has no problem working in various environments. It's designed for those areas. We also have a whole range of systems that can be configured or optimized for whatever type of situation we're in. So it's not just a case of we have one particular system and we shoehorn it into whichever application you want. Whichever application you have, we'll have a system designed and optimized for that already. So that's all of that side. So what do we do once the system has identified there's a hotspot and it's giving us, it has identified the X, Y, and Z coordinates of it? We send those coordinates to our monitor controller. That will then aim the monitor at that location in 3D space. So it's not just putting it down a particular vector, it will actually aim for a point in space. And then it will fire, it will open the solenoid valve to allow water to the monitor, and we'll cool that area with a pre-programmed pattern. We don't just hit the center of the hotspot, because that has a risk of sending hot material outside the spray area. We actually start in one corner and work our way over it, and then we come back and forth several times to make sure the area is cooled. We can also include foam proportioners in here if you want to have a wetting agent or a foam, although that's pretty unusual for clients to do that. While we're cooling, the PyroSmart is still scanning the rest of the facility, so you're always covered there. And then once once the cooling cycle is complete, the PyroSmart will come back and check that area and make sure there's no residual heat there, and then go back to scanning the full facility. So you've still got 24/7 cover. There's never a time where you fire the system, then it's down while you wait for material to be reloaded, or you've got to fill up a container or anything like that. The system is hooked into essentially your sprinkler main, so you've always got water available. You can use it multiple times a day if you require. So when manual control is needed, there may be times where, although it's automated and that's really good, you may just want to manually take over. That's not a problem at all. We have a portable remote control module that can control up to 4 monitors. As soon as you turn that on, it will connect wirelessly to the system, and it will take over from the autonomous control. So you instantly have manual control. You can then aim the monitor, you can change the spray pattern, you can turn the flow on and off. And then once you're finished that, if you forget to turn the panel off, that's no problem. After 2 minutes of no action on the panel, the system will automatically revert back to autonomous control. So you're always covered. So I thought now would be a good time to let you see how the system operates in real time. This is a facility in Germany. As the video starts, it's just as the PyroSmart system sees the hotspot, you'll see it move and then stop. So here we go. So that's it, spotted it. It then goes up and checks its box, electronics box, comes back down, does that to make sure it's seeing a change in temperature, so it knows it's a real temperature. It then checks to make sure it's not a false alarm, sends the 3D coordinates to the monitor, and then goes back to scanning. So you can see that's the PyroSmart scanning the rest of the hall while the monitor is now activated. So you're normally looking at around 20 seconds, 10 to 20 seconds from detecting a hotspot till the monitor's on location, and you'll see it now. And that's it, going over a grid pattern over the area where the hotspot was detected. And you can see we can cover very large areas with one system. So where is it used? We work in a number of different industries. Material recycling, MRFs are very popular for us, the pulp and paper industry, various waste treatment facilities, transfer stations are a very common application for us, as well as wood processing and some forest management. If you're going to have materials sitting outside for some time and there's a risk of fire there, we can do that. Although the applications I have shown have pretty much all been indoors, the system works outdoors. We use it for solar panel fields where we're monitoring the entire area. So there's various things we can do there as well. So in summary, the system that we have, it delivers outstanding results. One of the advantages is it's faster than any human-led system. So we're not going through all the detection, then sending out a signal to a remote human somewhere, and then relying on them coming online, checking the system, and then aiming it. It will do all of that automatically, far faster. It will also send out the alerts so that us humans are aware of what's happening, but we won't be the bottleneck. Because we're detecting much earlier and taking action much earlier in the fire propagation cycle, we have a lot less interruption to your operations. It takes a lot less water to cool a hotspot as opposed to extinguish a fire. So both of those really help. That makes it ideal for any high-risk environments, especially if there is a risk of lithium-ion batteries being present. So we work really well in those environments. We don't require any interface from your personnel day to day, hour to hour. You just set it and it runs. As I said earlier, you can take over at any point. That's no problem, but it will just continually run. And with that, you have fewer false alarms and greater accuracy. False alarms will just leave people frustrated with the system, and there's a likelihood they'll start to try and circumvent it. We don't want that at all. So the system with the false alarm detection is absolutely critical. And that's everything I have for you. Thank you for your attention.
Well, thanks, John, for that presentation. It's very interesting. And as you explained in the beginning of your presentation, obviously there's a growing need for this with lithium batteries being used more and more in everyday life, and then obviously being in recycling parts. First thing I wanted to ask you was, what are the sort of regulations for these sort of situations in terms of having fire protection systems? Is it mandatory for them to have them?
It's not mandatory to have this level of fire protection. A general sprinkler system is all that is generally required, and our system certainly doesn't necessarily remove the requirement for a sprinkler system. Sprinkler system is a full building, a full facility, a fire suppression system. So if something got completely out of hand, one monitor on its own probably wouldn't be able to do it. So you still need to have your fire suppression, generally a sprinkler or some sort of other deluge system in place. What we're in there for is to prevent it ever getting to that stage. If you get to the point where you have to activate your deluge system, you already have damage to the facility. You've got massive impact to your operations, which can run into days or weeks, or in some cases months of delays. So our system is in there to augment and support all of that, and hopes to mean that you never need it.
Yeah, I mean, I suppose that's exactly the whole point of the system, really, is it? It's being used in a situation where it's actually going to prevent those big fires before they get to that point.
Yeah, and we call it's a fire prevention system we have, but in actual fact, we should never see fire. The system has failed to get to that point. It's a cooling system in practical day-to-day operation.
Yeah. What I was going to ask, the other question I was going to ask was in terms of its running costs. How does that equate with maybe other systems?
Well, the running costs are pretty straightforward. We have gone with the buy once, cry once pricing model. So you come to us, we'll give you a quote to install everything. That's it. From then on, you own the equipment. There is no monthly charges. There is an annual charge for software, but that's not substantial. But there's no monthly charges. There's no operator charges. There's no restocking, refilling charges. If you use the system, you can use it as many times as you want. I have some clients who, because it's so flexible, you can aim the monitors with the manual control. They like to use it for cleaning off the top of some of the machinery in the area. It's not really what it was designed for, but it does an excellent job of it. So it's yours to use and as you wish. So the pricing model is pretty straightforward. There's no hidden costs.
So it comes in handy just for doing the cleaning tasks as well as the fire prevention as well.
Yeah, it was never our primary goal to do that, but it's one of the benefits of the system.
Well, that's very useful as well. Perhaps you should add that to the presentation as an added benefit. So in terms of a client coming to you and thinking about how they might have a system like this installed, how does that process begin, and how do you undergo that first approach from a client?
Okay, there's a couple of steps to it. The first thing we generally ask for, other than a conversation and that sort of stuff, is for some plans of the facility, and marked out on those plans is the areas that they wish to protect. I'll ask a bunch of questions about how high retaining walls are and where machinery is, so we can make sure that the PyroSmart system actually has a clear line of sight, and the monitors have clear lines of sight to wherever the client needs to get to. So we can do all that reasonably quickly, and we'll give them a budget proposal based on that, so they have a ballpark figure. If based on that they wish to proceed, then I'll come up and I'll do an actual site inspection, where I'll bring up a video drone with me, and I'll actually fly that up to where the camera would be. We'll be able to see what the PyroSmart would see, so we can adjust the potential position. So if we need to see inside a drum loader or a baler, we can actually see what the view would be. And then I'll do all the measurements, so that at no point is it going to come back to the client where we supply a system and we can't see or we can't perform as expected because they gave us the wrong information. That will never be the client's responsibility. That's our job. So I'll come up and do that site inspection, and then from that we'll have a definite proposal we can give the client. And then from there, it's normally a 3 to 4 month lead time between getting everything installed and having the system up and running.
Well, it's certainly very interesting, John. And as we sort of reiterated, the need for this kind of system seems to be growing all the time, particularly, as you said, with the lithium battery sort of proposal, and in fact, an increase in recycling generally and recycling plants, and also all the other applications that you mentioned as well.
Yeah. Yep.
And in terms of people wanting to get in contact, I suppose they can go to the ACEDES website. I think it's ACEDES.com, is that right?
ACEDES.com, you'll find me there. It's got all our contact details, and I'd be happy to talk to you. And if you need something outside of North America, our parent companies in Germany will be happy to take care of you.
That's great, John. Thanks very much for your time. It's been a very interesting presentation, and have a good rest of the day. Anyway, thanks very much.
Thank you very much, Ed. Thank you for everyone for giving us their time. Thank you.
Cheers, John. Thank you. Bye-bye.